So we've had a very interesting journey so far. My first experience of using augmented reality was back in 2005, where for the first time I put on one of these head-mounted displays, and I was actually participating in one of the experiments that a lab in computer science department at the University of British Columbia. I immediately realized what are the things that still could be improved on this type of technology that would make it practical and something that somebody like myself with civil engineering background would be able to use. So this led me to the research on D4AR, the four-dimensional augmented reality, which was a different type of augmented reality environment in the sense that it was not really connecting people on the site with information. Rather, it was a process of figuring out how we can automatically detect, for example, progress or quality on the job site. The original idea behind this technology was just to take photographs on construction sites and then being able to map that with respect to three-dimensional models that in construction we typically call them building information models. So the idea was to see how we can automatically detect what we typically call as progress on job sites. Back then we didn't have any intention of being able to connect people who are on the site with this level of information. So after this was tested on Eikenberry Dining Hall project, I started working on a new idea on top of this. And the idea was how a picture that is captured on a smart device could be mapped against such an existing environment, and that's why we call it hybrid four-dimensional augmented reality. Really, the research started with the notion of figuring out how we can create this sort of client-server mode where a picture that is captured on a smart device with very high accuracy and at a very minimal computation time could be mapped against that space. So this led us to a research project that was funded by National Science Foundation. We started this project in less than a year. We came up with a prototype of this technology, which is almost independent from what we had in the past. And this is the capability of mapping a new image to the scene. After doing a number of testings last summer, we were approached by a venture capitalist from Boston, Allied Minds, which invested in the idea. So we licensed the technology out to start a company, PowerWorks Inc. And we've been operating for almost about a year now. Over time, as we've been talking to different people and seeking their interest into this, we've realized that other people see different types of application. One thing that I can make an example of is a new app that we've come up with, which is Mars Standard. Now, Mars Standard is an app that has the capability of detecting changes in the scene. For example, you could be standing in a Dunkin' Donuts store and you're looking to one of the kiosks that they have in the store. And what you can do is you can take a picture of that kiosk and we can detect different objects that happen to be sitting on that shelf. Now, one of the things that was asked from us was to see whether we would be able to detect how much changes has happened, so sort of planogram synchronization process. So we've actually been able to achieve that, so that's been something that we've recently developed. And now we have the capability of detecting how many boxes, for example, has been removed from one particular shape, or whether there's a need for sending a signal to our inventory management platform and let them know that there's need to be more sort of products to be added to the shelf. Yeah. Taking a picture of the site, it's going to a server. Like I said, the server is sitting on Amazon EC2. So it's being processed to figure out where this image is being captured from, and then it's being pushed back to the device, and it comes back with the information. So now again you have the information that is being augmented on the photo. So I'm clicking on it, it's really nothing. It's just a simple white box that I've added. But again, it shows you the information that has been previously embedded into the scene. So we've just rolled out HD4AR version 2, which stands for Hybrid Four-Dimensional Augmented Reality. This technology comes at a much higher accuracy and faster localization speed that we had compared to our previous version. So now we have the capability of generating complete three-dimensional models for various sites, particularly for construction or facility management purposes. now you would be able to much faster generate complete models of an entirety of a building, and then you would be able to easily connect field engineers to all sorts of information, whether those information happens to be specification of the project, whether they want to access daily progress monitoring forms, whether this happens to be a quality control sort of form. So again, accuracy and computation time are definitely the significant progress or achievements that we've been able to make out of our new work.